So we are still on continued. And discontinued. Okay. Still examples. One, sketch f of x is equal to x plus 3 minus x minus 4 and determine whether f of x is continuous at x is equal to -3. Just 1 point is enough. What's important here is I want you to learn how to sketch this. Okay, so sketch and determine whether the function is continuous at x is equal to -3. So how do you sketch such functions? The first step is you redefine. Redefine f of x without the modulus. So you get each piece and redefine the piece. This is the same as x plus 3, provided x plus 3 is greater or equal to 0. This is negative x plus 3 when x plus 3 is less than 0. But this is x plus 3 when x is greater or equal to -3. This is negative x minus 3 when x is less than -3. You also get x minus 4. Redefine when x plus 4 is greater or equal to 0. X plus 4 is less than 0. And then x plus 4 when x is greater or equal to -4. Negative x minus 4 when x is less than -4. Then from that, you make a table of values table values with these two numbers, -3 and -4. So put -4 here and -3 here. And then draw tables in here. We'll be looking at the interval x less than -4. Then we also have the interval -4 less than or equal to x less than -3. Another interval x greater or equal to -3. And then we pick the modulus of x plus 3, the modulus of x minus 4, and then we form the function f of x. Then we go to the piecewise redefinition of each piece. What is the value? Which function do we pick? Which piece of this function do we pick in the interval x less than -4? So you go to the functions. We are talking about these functions. When x is less than -4, which piece here is going to be satisfied? You notice that it only happens when x is less than -3. This is the only interval that will intersect with that interval. So at the intersection, it will satisfy that interval. So the modulus of x plus 3 is going to be -x minus 3 in the interval x less than -3. I mean x less than -4. In the interval x less than -3 but bigger than -4, this is still satisfied. So we'll have -x minus 3. When x is greater or equal to -3, we are getting x plus 3. And then when x is less than -4, the modulus of x minus 4 is -x. What happened? Oh, I put a negative here instead of positive. I put a positive instead of negative. So this one becomes positive. So get -x plus 4. And then when x is greater than -4, but less than -3, the function still uses x plus 4. When x is greater than -4, you satisfy the interval x greater than -3, so we have x plus 4. Okay, so I'm writing 4 plus 4 because I made a mistake there. So we do that correction. So it's x minus 4. It's x minus 4. So that even inside here, we have x minus 4. Okay. It's x minus 4. So now we are looking for f of x. So we do the addition in each column. So -x minus x will give us -2x. -3 plus 4 will give us +1. And here we'll get -7. And the other one will get 2x minus 1. Okay. So this means that our function f of x can now be written as f of x is equal to a piecewise function -2x plus 1 for x less than -4 and -7 for -4 less or equal to x, which is less than -3, and 2x minus 1 for x greater or equal to -3. So when it comes to sketching, we are sketching this function now, which looks easy now. So we have -4 and -3. So when x is less than -4, we are using that piece on top there. So f of x is equal to -2x plus 1 when x is less than -4. So if we substitute -4, we're going to get -2, -4 plus 1. And this is 8 plus 1, which is 9. So we have -4, 9. And it will be an open hole there. Then we get back and say, okay, what of at -5? So f of -5 is going to be -2, -5 plus 1. This is 11. Something bigger than that. So we're going to get 11. Which goes on top like this. Just a recheck. Something looks awkward. Oh. Which one? Just a second. From left. One on top. Okay, so here we need to redo the addition. This function has a minus here. It has a minus here, which we didn't take into consideration. We just did this plus this, so we are adding the pieces. So we need to involve that negative there. So realize this. When sketching, I noticed that something was wrong. So that here, this should wait. So we need to wait. Okay. So we get back. So in the first column, it will be -x minus 3 minus -x plus 4, which is -x minus 3 plus x plus x minus 4, which is -7. So -7 is here. The middle one has -x minus 3. And then I've made so many mistakes. So it's not adding up. Okay. So it's more like work done equal to negative. Work done equal to -4. Okay. Let's do a quick restart. The one who's going to suffer now is Janet, because she will have to watch and reach here and restart. It will be nice. So we get x plus 3, redefine, we'll have x plus 3 when x plus 3 is greater or equal to 0. Then we'll have negative x plus 3 when x plus 3 is less than 0. This is giving us x plus 3 when x is greater or equal to negative 3. Negative x minus 3 when x is less than negative 3. Then the other one, it's x minus 4. This is where I had made a mistake. So x minus 4, so x minus 4 greater or equal to 0. And then negative x minus 4 when x minus 4 less than 0. This is the same as x minus 4 when x is greater or equal to 4. And negative x plus 4 when x is less than 4. So now we are using these two numbers to give us the table, negative 3 and positive 4. This is where the table is going to come from. So for the first one, the modulus of x plus 3, the modulus of x minus 4, and then f of x. X less than negative 3, negative 3 less or equal to x less than 4, and x greater or equal to 4. So when x is less than negative 3, we are getting, for x plus 3, we are getting negative x minus 3. This is the interval. And when x is bigger than negative 3, for this interval, for this one, we are getting x plus 3. And it remains bigger than 3, even in here. And then for the other one, when x is less than 4, that's the interval which will intersect with x less than negative 3, which is negative x plus 4. And then when x is less than 4, we'll get still the same, negative x plus 4. And then the other one, when x is greater or equal to 4, we'll get x minus 4. Then putting this together by subtraction. So we get negative x minus 3 minus negative x plus 4, which is negative x minus 3 plus x minus 4, giving us negative 7. So that still come out to be negative 7 still. And then the other one, x plus 3 minus negative x plus 4. This will come out to be x plus 3 plus x minus 4, which is 2x minus 1. So we have 2x minus 1. And our subtraction is x plus 3 minus x minus 4. That is x plus 3 minus x plus 4. So we get 7. So we'll have 7 there. And then we sketch. So we'll first write our function. We write our function. So we have negative 7 when x is less than negative 3. And we have 2x minus 1 when negative 3 is less or equal to x, which is less than 4. We have positive 7 when x is greater or equal to 4. Now, constant functions are very, very easy to sketch. against -3, when x is less than -3, we'll be getting -7. So you start at an open hole and fix -7 throughout. For n number where x is less than 3, you're getting a constant -7. Then after 4 again, so that was for this one. After 4, we'll be getting 7, including 4. We'll be getting 7. And then we now substitute for the interval in between. When x is -3, f of -3 is going to be 2 -3 minus 1, which is -6 minus 1, which is -7. So we'll come back and close here. Or to show that we had to come back to close, let's close using a blue ink. So come back and close there. And then once you do that closing, when x is in this whole interval, we can let's see what it is when x is 0. What is f of 0? F of 0 is 2, 0 minus 1, which is -1. So it's crossing at -1. And let's see how far it goes. When x is 4, we'll get 2 by 4 minus 1, which is 8 minus 1, which is 7. So we're going to have a function here going all the way up to there. This here, come and enter there. And it's crossing when x is -1. This one here is half. We just equate the same piece to 0. We get x is half. Like that. So this is the sketch. Then now we find the limit at x. When we check continuity at x is equal to -3. Check the limit at x is equal to -3. We check if the function is defined at -3, and it is defined. We are getting -7. As you can see, we got -7 there. Then 2, we check for the limit as x goes to -3 from left of this function. So I'm going to use this line, which is -7. So we'll get -7. We also get the limit as x goes to -3 from right. From right, we are using the middle part, which is 2x minus 1, which is 2, -3 minus 1, which is -7. So we'll get -7 again.
Why is the solution for that question? Box what?
What do you mean book? There's no books there in that direction. Okay, so the last step, we are just checking if, so here, because the limits are the same from either side, so we are saying the limit as x goes to -3 of f of x is -7. But just when you check in the first step, we also get -7. So the function is continuous. F is continuous at x is equal to -3. This is how you check. This is how you sketch.
Did you get the photo?
Oh,
What's that?
any questions?
So I've got a question.
Okay.
Like here where it's at -3, -7. At the beginning we opened it. Why have we closed it now?
Because we have found a function that is closing it. So at the beginning it was open because -3 was not included. Then we found one that was closing now, which is the second function, which gave us the same -7. So we go and close using the second piece, which is 2x minus 1. Okay, so we'll have to log out and log back.